Hello everyone. This video would focus on conic section, specifically on hyperbola with center at 0, 0 or at the point of origin. And this is the 10th part. In this part, we're supposed to determine the standard equation of a hyperbola where given the center, the coordinate of the vertex, and the eccentricity. Before we go further, please feel free to check out the description box below for the link of the other series of topics related to hyperbola with center at 0, 0. Before we jump into this example right here, let's have a review on the parts, the two cases, and the equations of hyperbola with center at 0, 0 or at the point of origin. Please notice that this hyperbola is called the horizontal hyperbola because the graph, which is in red, which is the hyperbola, is touching the horizontal axis. Now, these are the parts. The first part is the center. The center is located at 0, 0 or at the point of origin. Another part is the vertex. There are two of them. We call them as vertices. Another part is the transverse axis. The transverse axis is the line that connects the two vertices passing through the center. Another part is the co-vertex, and there are two of them. We call them as co-vertices. Another part is the conjugate axis. This is the line connecting the two co-vertices passing through the center. The next part is the focus. There are two of them. We call them as foci. Please remember that the focus is located to the side where the hyperbola or the branch of the hyperbola opens. Another part is the latus rectum. This is the line segment with endpoints on the hyperbola and it passes through the focus. And there are two of them for each side. The next part are the asymptotes. These are the two lines that form an X shape where the hyperbola approaches but never touches it. We call them again as asymptotes. The equation of the asymptote with a negative slope is y equals negative b over a x, while the other asymptote with a positive slope is y equals b over a x. Now, the easiest way to draw the asymptote is by drawing a rectangle covering the 4 points, the two vertices, and the two co-vertices. And the two asymptotes are actually the diagonals of these rectangles extending outward of the rectangle. So that's a trick on how to approximately draw the two asymptotes. Now, let's look at some important lengths of hyperbola. The first is the distance from the center to the vertex is represented as letter A. The distance from the center to the co-vertex is represented as letter B, while the distance from the center to the focus is represented as letter C. From here, we can go ahead and say that the length of the transverse axis, that is from one vertex to the other vertex, is a formula of 2a, while the length of the conjugate axis, that is from one co-vertex to the other co-vertex, is 2b. Now, the equation that relates all these three lengths here, a, b, and c, is c squared equals a squared plus b squared. We also have another quantity called eccentricity. Eccentricity is defined as the measure of how oval the hyperbola is. And the formula for the eccentricity is C over A. Now, we remember that eccentricity for a hyperbola is always greater than 1. Now, the standard formula for a horizontal hyperbola is x squared over a squared minus y squared over b squared equals 1. Now, please notice this. Since our A is on the horizontal axis, we therefore placed it under the x squared. And since our vertex is on the horizontal axis, the x squared over a squared is positive. Now, let's look at the second case of a hyperbola, which is the vertical hyperbola. In the vertical hyperbola, we still have the same parts. And the equation of the asymptote with a negative slope is y equals negative a over bx, while the one with a positive slope is y equals a over bx. We also have these lengths in a vertical hyperbola. We also remember that the standard formula for a vertical hyperbola is y squared over a squared minus x squared over b squared equals 1. Now please notice that our vertex is on the vertical axis. That's the reason why our A is under the Y. Remember, Y means up or down. And that's the reason why the A squared is located under the y squared. Now, we also remember that our y squared over a squared is positive because this is a vertical hyperbola. So these are the parts, the two cases, and the equations of a hyperbola with center at 0, 0 or at the point of origin. Okay, going back to the problem right here, we are given the center. So I'm going to go ahead and plot that center right here. So this is our center at 0, 0. And then we have a vertex at 0, 3. So that would be up here. So this is our vertex. Now we remember that the center of the hyperbola is the midpoint between the two vertices, the midpoint between the two co-vertices, or the midpoint between the two foci. This tells us that since this is the distance from the center to the vertex, the other vertex would be down across with the same distance. So this is where the other vertex is gonna sit. So if you notice, our center is actually the midpoint between these two vertices. As you can see right here, since these two vertices are vertical relative to each other, we can go ahead and say that this is an example of a vertical hyperbola with center at 0, 0. So I'm going to go ahead and write that information up here. Since this is an example of a vertical hyperbola, we can go ahead and write the general equation for a vertical hyperbola right here. So that is y squared over a squared minus x squared over b squared equals 1. Now we remember that our A is the distance from the center to the vertex. From here, we can go ahead and say that our A is equal to 3 because that is center to vertex 1, 2, 3. So that we can go ahead and plug this 3 into this equation right here. If you notice, I left the b squared blank because we don't know what our b value is. So we can go ahead and write b is equal to blank here. Again, we don't know what it is. We're going to solve for it. But since we don't have a b, however, we are given the eccentricity value, which is 5 over 3. We remember that eccentricity is equal to c over A. And again, our eccentricity is 5 over 3 is equal to c over A. Looking at this, our A is equal to 3. That's what we got right there. Our c is equal to 5. So then we can go ahead and write that down here. Our c is plus minus 5. This tells us that we go... By the way, the C represents the location of the focus. That is 5 distance from the center. So I go up 5 and down 5 to determine the location of the two foci. So this is our first focus and this is the other focus. So then we can go ahead and write the coordinates of the two foci down here. Okay, so we've determined the value of C. However, we're supposed to determine the value of B so that we can complete this equation right here. Now, we remember since we already have an A and C, we remember that the equation that relates A, B, and C is C squared equals A squared plus B squared. I'm going to go ahead and write that up here. So we're going to plug the values in. We already have a C, which is 5. So I'm going to go ahead and write that up here. C is 5. We're going to square it. Our A is 3. So I put that up here. That's 3 squared plus B squared. This tells us that this would be 25 equals 9 plus b squared. So we're going to solve for b. We're going to subtract 9 from both sides. That's minus 9. So we subtract 9 there. So then this comes out. B squared is equal to 25 minus 9 is 16. And so then our b is plus minus 4. So we go ahead and write that up here. So our b is 4. So then we can plug the value of b in here and come up with the equation for this hyperbola. So this is the equation for this problem that we have up there. And since we have a b of 4, that is the distance from the center to the co-vertex, that means I go to the left 4, right 4, and we are able to determine the location of the co-vertex. So this is our first co-vertex, while the other co-vertex is going to be located to the right of the center. So then the coordinates of these two co-vertices would be... Okay, from here we can determine the length of the transverse axis, that is the distance from the vertex to the other vertex, and the length of the conjugate axis, that is the distance from the co-vertex to the other co-vertex. I'm going to go ahead and show that work up here. Okay, so the length of the transverse axis is 6, while the length of the conjugate axis is 8. So that from here, we can go ahead and sketch the central rectangle. Okay, we remember that the central rectangle of a hyperbola will pass through the two vertices and the two co-vertices. From here, we can draw the two asymptotes. Remember, the two asymptotes would come from each opposite corners of the rectangle, passing through the center. So these are the two asymptotes. The equation for this asymptote right here would be having a negative slope. So that is y equals, remember, we go up and over to get to the other corner of the rectangle. So I go up 1, 2, 3, and that is over 1, 2, 3, 4. That's over 4. I put negative to it because I went to the left. So that is y equals 3 over negative 4x. Well, the other one right here, I go up 3, 1, 2, 3. And then I go to the right, 1, 2, 3, 4 to get to the corner of the rectangle. And that's positive because I went to the right. So this is the equation of the asymptote with a positive slope. And so we're now ready to sketch the graph of this hyperbola. So this is the equation of this problem that we have right here. And this is the graph of this equation. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. We are given the center of this hyperbola, which is at the point of origin or 0, 0. We also have a vertex, which is on negative 4, 0. So this is our vertex right here. Now we remember that the center of the hyperbola is the midpoint between the two vertices, the midpoint between the two co-vertices, or the midpoint between the two foci. So in this problem right here, we are given the vertex and the center. Now we remember that this center is actually the midpoint between the two vertices. This tells us that the distance for the other vertex is the same distance from the other vertex. So it's going to be across, and this will be the location of the other vertex. So that we can go ahead and add that coordinate of the other vertex right here, which is at positive 4, 0. Now looking at this, these two vertices are horizontal relative to each other, and it has a center of 0, 0. This tells us that this hyperbola is a horizontal hyperbola with center at 0, 0. I'm going to go ahead and write that information up here. Since this is an example of a horizontal hyperbola, the general equation of a horizontal hyperbola is x squared over a squared minus y squared over b squared equals 1. Now we remember that the value of a is the distance from the center to the vertex. So in this problem right here, our a is, we just counted, 1, 2, 3, 4. Our a is 4. So we go ahead and plug that value of a up here. If you notice, I left the b squared blank because we don't know what the b is. However, we're given the eccentricity. We remember that eccentricity is equal to c over a. So I'm going to plug the value in, which is square root of 5 over 2, and that is equal to c over a. And since our a was 4, we plug it in here. So this comes out square root of 5 over 2 equals c over 4. Because again, our a was 4. So that we can go ahead and cross multiply this. So this is gonna, it's gonna look like this. So this would be 4 square root of 5 equals 2c. We're going to solve for c, so we're going to divide both sides by 2. We divide this by 2 and divide this by 2. We are left with c is equal to, we can reduce this to the lowest term. 4 divided by 2 is 2. So then our c is actually 2 square root of 5. This tells us that our c is approximately plus minus 4.47. So this is our value for C. C is actually the distance from the center to the focus, which is 4.47. And so the first focus would be located right here. So that's negative 4. So 4.47 should be somewhere there. That's our focus. And the other focus would be 4.47. That should be in between 4 and 5. That's the other focus right there. So we can go ahead and write the coordinates of the two foci up here. Okay, we already have a value for A. We also have a value for C. Again, to complete the equation, we need the B squared so that we can go ahead and use the equation C squared equals A squared plus B squared to solve for B. I'm going to go ahead and show that work up here. Okay, we've solved the value of B, which is 2. So I'm going to put that in here. So what we would do is we are going to plug this 2 into the B here to complete the equation of this hyperbola. So then our equation would come out. So this is the equation of this problem that we have up there. Since our B is 2, remember B is the distance from the center to the co-vertex. So then we go ahead and count 2 up and 2 down, and that's the location of the co-vertex. So this is our first co-vertex and this is the other co-vertex. I'm going to go ahead and write the coordinates of the two co-vertices up here. Okay, so that from here, we can go ahead and draw the central rectangle and the asymptote for this hyperbola. Okay, so the equation for these two asymptote is y equals 2 over negative 4x, or you can change this to negative 1/2 x, and then the other one would be a positive 1/2 x. So that from here, we can go ahead and determine the length of the transverse axis. That's the distance from the vertex to the other vertex, and the length of the conjugate axis, which is the distance from the co-vertex to the other co-vertex. I'm going to go ahead and show that work up here. So if you notice, the length of the transverse axis is 8. So if we count the distance from the vertex to the other vertex, that's 8. Well, the length of the conjugate axis is 4. That is the distance from the co-vertex to the other co-vertex. So that we can go ahead and sketch the hyperbola from here. So this is the equation of this problem that we have right here, and this is the graph of this equation. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!